does not at all build on 14.3, where we looked at trig identities, but it does build off of stuff that we did back in chapter 13 with our special triangles. So those 30, 60, 90, and 45, 45, 90 triangles are going to be important to us in this lesson. We have 4 steps to solving a trig equation. You can write these down if you want or not. These are the 4 steps that we'll be going through in every one of our examples. The first thing we're going to do is get the trig part alone. So the sine of x, cosine of x, whatever happens to be, we're going to get it alone. The second thing we're going to do is use SOHCAHTOA and our special triangles to find our angle in radians. We're always going to be working in radians when we solve an equation. The third step is to figure out in which quadrants the answer is in using ASTC, which is a rule that I will explain as we go through the first example. And our last step is we're just going to throw a plus 2 pi n onto the end of our answers. And I will explain why we do that when we do the first example. These same 4 steps every single time. So, first step is to get the trig part alone. So what do I do first to do that? Add 1 to both sides. And then? Divide by 2 on both sides. So that is your first step to every problem. Get the trig part alone. Second step, use SOHCAHTOA to figure out what kind of angle we are talking about. So this is similar to what we did back in section 13.4 when we looked at inverse trig, because inverse trig is solving for an angle. So what we want to know here is, what is SOHCAHTOA for sine? Opposite over hypotenuse. So which triangle has a hypotenuse of 2 and also a 1 in it? The 30, 60, 90 has a hypotenuse of 2 and also a 1 in it. Then we need to select the appropriate angle from that triangle. So in that triangle, our equation says opposite of 1, since 1 is on the top and sine is talking about opposites. So what angle is across from the 1? 30. The 30. We want our answers to be in radians. So when we did our conversion, we said 180 is equal to pi, and 30 goes into 180 how many times? 6. So that is our second step, is to figure out which angle this equation is talking about. Our third step is to find in which quadrants our answer belongs. Now I'm going to draw a picture. You don't have to draw this picture if you don't want to, or you can if you think it will help you to be able to refer to it. There are 4 different ways I could draw a 30-degree angle. I could draw it in the first quadrant, second quadrant, third quadrant, or fourth quadrant. So I get kind of a little bow tie here. If I label the sides of those triangles according to either being positive or negative, up in the first quadrant, everything would be positive because sides are to the right, up, and hypotenuse is always positive. So that means if I took any sort of fraction of those sides, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, everything would end up being positive because all the sides are positive. So I'm going to label that quadrant with an A that stands for all. In the second quadrant, up is positive, hypotenuse is positive, but left is negative. So some of our trig answers would end up being negative there. Which one would end up being positive? Sine, because opposite and hypotenuse are positive. Opposite and hypotenuse is sine. So I'm going to label that quadrant with an S for sine. In the third quadrant, we already have the negative left labeled. We also have a negative down, and hypotenuse is positive. So in that quadrant, which trig function would end up being positive? This is the trickiest one. Tangent, because we need that double negative to give us a positive. So I'm going to label that with T for tangent. Now, by process of elimination, you could probably figure out this last one, but if I label negative and positive, which trig function uses the positives? Cosine is adjacent over hypotenuse. So that is our ASTC rule. If you remember those letters, ASTC, you can save yourself the time of drawing these pictures for every single problem. Math teachers for years have used the little mnemonic device, all students take calculus. I don't like that because it's not true, but that's how I learned it, so that's what always comes to my mind. But you can make up any sort of statement you would like to remember the letters ASTC going around, because our third step in solving is to figure out which quadrants our answer belongs in. So in our equation, we are working with the sine function, and we had a positive value because it was sine as positive 1/2. So I want to know in which two quadrants will sine be positive. A stands for all positive, S stands for sine positive. So in those two quadrants, I would get a positive answer for sine.
So we say quadrant 1 and 2?
We don't actually need to name the quadrants as part of our answer. This is still just part of the step along the way. This is still just in the work process, not the final answer process. So if I would draw our angle in those two quadrants, in the first quadrant, our angle just is what it is. Because starting at the 0 line and going up just a bit, we just get that base angle of pi over 6. In the second quadrant, starting at our 0 line and coming around, to think about where we would end. How big is half of a circle? 180, or in radians, pi. If I get a common denominator with the question, I can say that it is 6 pi over 6, because that's still just pi, which is 180. But I'm not making it all the way to that line. I'm stopping short of there. So if I stop a little bit less than 6 pi over 6, where am I? 5 pi over 6 is a little bit less than 6 pi over 6. Or you can think about, back when we learned about graphing trig, we learned that when we graph in sixths, we cut each half of the circle into 6 pieces, and count around how many pieces is that? That's the 5th piece. Okay, so we could think about it that way as well. Would still land us at 5 pi over 6. That is step 3, to find our angles in the appropriate quadrants. Final step, it said take those answers and throw a plus 2 pi n at the end of them. Okay, so now what does that mean? What is 2 pi?
Circle.
A full circle. N means any number of. So this says I can add any number of full circles I want. Well, what would happen? If I add a full circle to an angle, what happens to it?
It becomes the same thing.
It ends up right back where it started. That was what we did with our coterminal angles. We said you can go around and around and around and around, and all that really matters is where you end. So what that plus 2 pi n does, it says you could keep on going around in circles, and as long as you still end up at that same spot, it would still be a good answer.
So why do we have 2 answers?
Because there are 2 quadrants in which sine is positive. So you will always have either 2 answers or 4 answers. And we'll talk about 4 answers when it comes up in a problem. But you will always have either 2 answers or 4 answers for these questions.
Wait, what is the last step to the...
Adding the plus 2 pi n is the last step. All right. Let's go ahead and try another one.
Why do we add the 2 pi plus n?
The plus 2 pi n is what gives us those coterminal answers where we said you could go around a whole circle and land in that same spot and it would still be a correct answer.
So why is it 2 pi?
Because 2 pi is a full circle. 2 pi is 360 degrees. No. 2 pi.
Why are we giving answers in
In trigonometry, radian is actually considered the primary method. Part of that is based on calculus, that in calculus formulas, they're a whole lot prettier if we work in radians than degrees. All right, for the next one, What's our first step to getting the trig function alone? Subtract 1. And then divide by 4. So cosine of x is negative 1/2. First step, get the trig function alone. Second step, think about SOHCAHTOA. What is SOHCAHTOA for cosine? Adjacent over hypotenuse. So which triangle has a hypotenuse of 2 and a 1 in it? 30, 60, 90. And in that 30, 60, 90, which angle would I find adjacent to the 1? Because cosine talks about adjacent, and our value is 1/2. So I want to be adjacent to that 1. What angle is right there next to the 1? The 60, which is equal to, in radians, pi over 3, because 60 goes into 180 3 times. That's step 2, to find our angle from our special triangles, either 30, 60, 90 or 45, 45, 90. Step 3 is to think about our ASTC quadrants. Now, in our equation this time, we are working with cosine, and it says cosine is negative 1/2. So I want the quadrants where cosine would be negative. So which ones is it not going to be? It's not going to be A, because A means all are positive, and I don't want a positive answer because my equation says cosine is negative 1/2. And it's not going to be C, because C means cosine is positive, and I want cosine to be negative 1/2. So that means our answers are going to be in the S and T quadrants.
There's always two possible answers.
Always 2 answers or 4 answers. And we'll come up to 4 answers shortly. So now in those 2 quadrants, if I would draw my angle in the second quadrant, well, how big is half of a circle in this problem? How big is half of a circle? Pi. And in this question, we'll say that it's 3 pi over 3 because we're working with pi thirds. So if I land in that second quadrant, I don't make it all the way to 3 pi over 3. Where do I stop? 2 pi over 3. And in the T quadrant, when I pass by that 3 pi over 3, where do I land? 4 pi over 3, 1 past the 3 pi over 3. Or you can think about, like we learned when we were graphing our trig angles, dividing the circle into 3 pieces on top and 3 pieces on bottom, and that's where we'd want to ignore that vertical axis. Final step, throw on the plus 2 pi n, which just says we can go around in circles and still land at the same place.
Wait, so when we have 60, we divide up to
60 is 180 divided by 3, so we do pi over 3. So we're dividing into 3 pieces in each half. So when your answer is in the S quadrant, the numerator will always be 1 less than the denominator. When your answer is in the T quadrant, your numerator will always be 1 more than the denominator because it's going past that halfway point.
Alright. Alright, so n just means any number, like any variable?
Yes, n means any value, any whole number value.
Alright. So could you write 360x there?
If we were working in degrees, then we could write 360n.
But you can't mix that?
But we don't want to mix radians and degrees. But that's what it means. For our next one, what do we do first in solving this equation? Add 1. And then? Divide by 2. And we're not actually done with the first step because I want plain trig. I don't want sine squared. I want sine. So what do? Take a square root of both sides. So sine of x equals, how do I take the square root of a fraction? Not in your calculator, because it will give you a decimal, which will not be helpful to us with our special triangles. You do not need a reciprocal. Split it up. Square root of the top and square root of the bottom. Square root of 1 is just 1. Square root of 2 is not pretty, so we will leave it. And what do we get in an equation when we take a square root? Two answers. Which two answers? Plus and minus. When we solve a square root equation, we always get a plus and minus. Step 2, SOHCAHTOA. What is SOHCAHTOA for sine? Opposite of hypotenuse. So which triangle has a hypotenuse of square root of 2 and also a 1 in it? 45, 45, 90. So our answer must be 45, which in radians is, how many times does 45 go into 180? 4. Now in thinking about our quadrants for step 3, our equation says that sine could be positive 1 over square root of 2. Where is sine positive? In the first two. But our equation says that sine could also be negative. Where is sine negative? In the other two. So that means we will have 4 answers to this question. When we get a plus or minus is when we will have 4 answers. You will always have an even number of answers, 2 answers or 4 answers. 4 answers will occur when we took a square root in the solving process and ended up with a plus and minus.
There will always be 4 when there's a square root.
Yes, when we took the square root. If the original equation had a square root in it, that's not a thing. But if we took a square root because our equation said sine squared or cosine squared or tangent squared, then we will get all 4 answers because we need a plus and minus then when we take that square root. So, if our answers are pi fourths, we could think about cutting each half of the circle into 4 pieces. In the first quadrant, what would my answer be? Starting at the 0 line, going up just 1 piece would give us 1 pi over 4. In the second quadrant, 3 pi over 4. 4 pi over 4 would be the halfway, so if I go on to that third quadrant, I would get 5 pi over 4. If I go around to that fourth quadrant, what would I get? 7 pi over 4, because a full circle would be 2 pi or 8 pi over 4, and we're stopping 1 short of that full circle, so we're stopping at 7 pi over 4.
Why are we moving from 9 to 8?
Why are we doing what?
Like, the first time we only moved 45, and we jumped to the other one.
We want a reference angle of 45 degrees. So it's not how many degrees we are going, it is having a reference angle of 45 degrees. So that if I would close up and make those triangles, that I would be making a 45 with the x-axis. So we're not on our axis lines. We're in the quadrants. So in the first quadrant, your numerator will always be 1. In the second quadrant, your numerator will be 1 less than the denominator. In the third quadrant, your numerator will be 1 more than the denominator. And in your fourth quadrant, your numerator will be 1 less than double the denominator. And our last step is in all these, we need to write in that plus 2 pi n that says we can go around in circles and get more answers. If you check your answers in the back of the book, they will not necessarily write their answers the same way. You may see, for example, on this question, just 1 answer, but if you look at it closely, It's going to say that pi fourths plus, instead of 2 pi n, it's going to say pi halves n. We are not going to discuss in this class how to combine answers. What the book does is says writing 4 answers seems like a lot of work. So we're going to combine our 4 answers into being able to write fewer answers. We're not going to discuss how that works. We're just going to write 4 answers and stay away from that extra math step. So just beware in checking your answers that the answers in the back of the book might be different because of that. So if it's saying plus pi halves n or plus just pi n, know that they have actually combined some answers there. Okay? Questions? This question's directions are slightly different. We have this phrase that says on the interval of 0 to 2 pi. What that means is we don't want to keep on going around in circles. We just want to consider the first set of answers. We do everything the same except don't write plus 2 pi n. The solving process is exactly the same. We're just not going to add for those coterminal angles because we're going to say let's just look at the first set of answers. So what do I do first to solve this equation? Add 3. And then divide by 4. And then take the square root. And when we take the square root of a fraction, we take the square root of the top and the square root of the bottom. So I get cosine of x is equal to what? Square root of 3 over 2 and plus or minus because we took a square root in an equation. Second step, SOHCAHTOA. What is SOHCAHTOA for cosine? Adjacent over hypotenuse. Which triangle has a hypotenuse of 2 and also a square root of 3 in it? 30, 60, 90. And in that 30, 60, 90, since we're dealing with cosine and adjacent, what is adjacent or right next to that square root of 3? The 30, which in radians is pi over 6. Now, because of that plus and minus, our answer is going to occur in all 4 quadrants. So you don't even really need to draw it out if you don't want to, because that plus and minus is going to make us have all 4 answers. So in the first quadrant, what will my answer be? Pi over 6. First quadrant, the answer is the base angle. Second quadrant, 5 pi over 6, 1 less than the denominator. Third quadrant, 7 pi over 6, 1 more than the denominator. And fourth quadrant, 11 pi over 6, 1 less than double because we're almost making that full circle 2 pi. Questions?
How did you get that last little thing? Like in the box?
Thinking about cutting up the circle, since we're working with pi sixth, cutting up each half of the circle into 6 pieces. And then we always want to consider the angles that are closest to the x-axis. So the first one is 1 piece away. In the second quadrant, it would be 5 pieces away. And the third quadrant, it would be 7 pieces away. And the last quadrant all the way around would be 11 pieces away.
The reference angles are ones that rely on x-axis.
Reference angles are always defined as being next to the x-axis, yes. Okay. Questions?
Do the 0 not on
That from 0 to 2 pi just means that we do not need to include plus 2 pi n in our answer. We're just saying let's just give the first set of answers instead of saying keep on going around in circles, which is what that plus 2 pi n means. So the solving process is exactly the same. We just don't put the plus 2 pi n. What do I do first in this example? Subtract 1. And we're done with our solving for our first step because our trig function's already alone. Second step, SOHCAHTOA. We need fractions if we're thinking about SOHCAHTOA. So what do I do to make this into a fraction? Divide by 1. And what's SOHCAHTOA for tangent? Opposite over adjacent. So which triangle has 2 ones neglecting the hypotenuse? 45, 45, 90. So our answer must be 45, which goes into 180. How many times? 4 times. We do not have a plus or minus here. Our equation says tangent is negative. So in which 2 quadrants will tangent be negative? S and C. A means all are positive, and we don't want a positive answer. We want a negative answer. T means tangent is positive, and we don't want tangent to be positive. We want tangent to be negative. So we need the S quadrant and C quadrant. So in the S quadrant, what will our answer be? 3 pi over 4. And in the C quadrant, 7 pi over 4. Always 2 answers or 4 answers. 4 answers if we have that plus and minus. That comes from taking a square root. 2 answers otherwise. Questions? The last problem is actually unsolvable. You end up with 1/3. And there is no 3 in our triangles, so we can't actually solve that problem. So we'll just skip it. At least it doesn't solve to be a nice value. It is solvable. It's just not a nice value. So your homework is from 14.4, and this is due the next time I see you.